Today we're going to begin studying sequences. Sequences is all about finding patterns. So those of you that are good at finding patterns are going to do really well with this topic. Today we're just going to focus on how to find each term and different types of sequences that you'll deal with. And as we progress through this topic, you'll learn more about specific sequences and how you can create rules or find sums of those sequences with formulas. So to start off today's notes, there is a warm-up for you guys to complete, questions 1 through 3. So if you could please pause the video and complete those questions at this time. Here are the answers for questions 1 through 3. For the first problem, you are adding consecutive odd integers, so check to see you have those 3 numbers. For the second problem, there's different ways you can word it, but I noticed it was powers of 3 that were decreasing. You could also say you were dividing the previous term by 3 or multiplying it by a third. Either way, though, you should have 1, 1/3, and 1/9 as the next 3 terms. And then finally, question 3, notice the numerator never changed, but the denominator were powers of 5. So again, you can comment that it was denominator powers of 5, or you were multiplying each term by a fifth, or dividing each term by 5. Either way, you should have that list of values. Now, today, I wanted to start with looking at some key vocabulary for this unit, starting with what is a sequence. A sequence is an ordered set of numbers that can be finite or infinite. If your list, this is hard to talk and write at the same time. If your list has the ... that's saying that it is an infinite sequence. But a finite sequence would end. And we'll talk about the difference between these two more as we progress through the unit. When we talk about the terms of a sequence, we use subscripts. So the first term, if you go back to question 3, we call that a sub 1, a sub 2, a sub 3, a sub 4, and so on and so forth. When you're writing a rule, you use a sub n to talk about any term in the sequence. And we'll get into that more as we progress through the unit, as I said earlier. There are 2 ways to write a formula for the terms of a sequence. A term in a recursive sequence depends on the previous term. When you write a recursive sequence, there's a couple things. Oh, my screen freezes all the time. Oh, no, I wasn't watching Netflix on my iPad. What? Busted, right? So going back to this, sorry. So if you are writing a recursive sequence, the first thing you need to do is always state what the first term is. And then when you write a rule to find any term, you use a sub n equals, and somewhere in your equation, you have to have a sub n minus 1, because this means the previous term. We'll practice this, but I just want you to have this in writing on your note sheet, and then you can come back and look at this at a later time. Now, you might be doing a sub n times 3, or, a sub n minus 1 times 3, or a sub n minus 1 minus 2. So you'll actually have to fill in more numbers, but at least a sub n minus 1 does need to be there. The other type of sequence we're going to be looking at is an explicit sequence, and that's found using a formula. These are the easier ones where you can just directly sub in and find any term of the sequence using that formula. Another thing that we're going to look at with sequences is this idea of when you approach a specific value. If your sequence approaches a specific value, it's said to be convergent. It converges to a specific value. Whereas if it does not, we call it divergent. Hashtag so old. I was gonna say Katniss Everdeen, but now I'm just thinking about it. I don't think that was divergent. I forgot. Trace. I don't know, something like that. If you watch that movie. So let's get into this vocab. Let's talk about what it means, and obviously you'll have some practice to do after the notes. So for the first type of problem you're looking at, you are given an explicit formula. If they say find the first 5 terms of the sequence, this is just direct substitution. If you want to find a sub 1, you're just going to sub in a 1 for all of the n's and then simplify. So 1 squared is 1 times 2, 2 minus 3, I get negative 1. So that would be the first term of my sequence. Then to find the second term, I'm going to sub in a 2 for all my n's and then simplify that. So 2 squared is 4 times 2 is 8 minus 3, I get 5. To find my third term, it's very tedious. You guys are going to find that this gets very, like, same process over and over again. 3 squared is 9 times 2 is 18. 18 minus 3 is 15. And a sub 4, we're going to sub in a 4. So 4 squared is 16 times 2 is 32 minus 3, 29, my age, you know it. And then finally, a sub 5. So we're going to get the 5 squared 25 times 2 is 50 minus 3, 47. Not my age. Absolutely not. And then that would be the first 5 terms of this specific sequence. Now, they also said to find the 50th term, and this would be very possible with an explicit secret, because you can just directly sub in, and then you can do the math for this one. So let's just use the calculator to be safe. I feel like I've already made a few mistakes today, so let's see what I last Googled. Oh, quizzes. That's not trouble. I don't have anything bad there. I swear my kids use my iPad, so if you ever see anything weird, it could be because of them or just me. So we have the 50 squared, multiply that by 2, 5,000, minus 3. And then 4,997, how old I currently feel right now after all this e-learning. So that would be your other part of the answer when it's said to find the 50th term. Now, things get a little tricky when you try to close out your calculator. It doesn't work. Use a recursive formula, because a recursive formula means that you are given the first term. Remember how I said you're always given that first term. So that's actually helpful. Got our first answer. But the hard thing is finding each term that comes next. Notice if I want to find a sub 2, if I fill in a 2 for all the n's, so this is, obviously what we see first, but if I fill in a 2 here, what you get is a sub 2 minus 1 minus 3. Now, if I do 2 minus 1, notice that that simplifies to a sub 1, which basically means, remember I said this in the notes, this represents the previous term. Well, the previous term is a sub 1. If you want to find a sub 3, you need to know a sub 2, because that, again, represents that previous term. So what we have to do is we have to take that value of 4, because that's what the previous term is. We were told that a sub 1 is 4, and then subtract 3 to get an answer of 1. Now, to find the third term, again, you can fill in a 3, but you're going to see that when you simplify, you basically take the second term and subtract 3, which means we need to take the answer we just got, which was 1, and subtract 3 to get a negative 2 for our third term. So you can see how recursive are a lot more challenging than explicit, because with recursive, you need to know the answer that came before. If you don't have the term that came before, you can't find the next term. So that's the tricky part with this. So you are always taking that answer you found previously and then filling that in and finding what the next term would be. How many do we have to find? 5 here. So one more. So okay. You then would need to take that fourth term and subtract 3. So again, kind of going back to this tediousness, you'll see patterns right away. Do you have to show all of this work? No. But until you discover that pattern, it's highly encouraged that you do this. Now, you may have been thinking ahead and thought, well, how are we going to find that 50th term? Because think about, to find the 50th term, we would need to know the 49th term and subtract 3. Now, you can't just guess. I mean, we can't go back through this process and find all these terms. This would take forever. So you're going to learn later on that there are rules and tricks to doing this. But what I want you to note is that when you found the second term, and this is kind of introducing this to you, what we really did was took that first term and subtracted 3. And then every time we find a new term, we're taking what we got and we're subtracting another 3. So notice that this was my, let me use black, my first term. This was my second term, so I'd have to do 4 minus 3, and I'd get 1. So to get to my third term, I'd have to subtract 3 again. So notice that when you're doing this idea of subtracting that common value, you keep subtracting 3 from the answer that you got before. So if I said find the 50th term, and again, I'm going to show you rules. I'll justify this more later, but just kind of introducing you to this idea. What you could really do is take that starting value and subtract 3, but think about how many times you'd have to do it. If you want to find the second term, you only subtract 3 once. If you want to find the third term, you subtracted 3 twice. So if I want to find the 50th term as asked, I'm going to subtract 3 49 times. And again, we'll get into this. You're going to get into this formula where if you ever want to find a specific term, and it's what we call arithmetic, which is what this is, where we keep subtracting or adding a value, you basically take the first term and then you add to it the common difference, which in this case was -3 times n minus 1. Now, in this case, n is 50 because they want us to find the 50th term, and that's why it ends up becoming that common difference of -3 times 49. So that's probably a little deeper than I wanted to get, and I probably maybe lost some of you guys there. So if you don't understand that for today, that's fine. There's a formal note sheet that goes over it, but I just kind of wanted to start introducing you to that idea so you can see how we almost have to create this explicit formula in order to get the answer to a future term in a regressive formula, or recursive, recursive. So that would be -143. So again, if you don't understand how to do that now, no worries. It was just kind of introducing you guys to that idea here. So what I would like for you guys to do is pause the video at this time and complete the U-Try. And then when you're ready to look at your answers, please resume the video. All right, so if you have questions 3 and 4 completed, for question 3, you should have subbed in a 1, a 2, a 3, a 4, a 5. It's an explicit formula. So to find the 5th term, you need to know nothing about any other terms, and you should get that sequence that we see here. We call this an alternating sequence where the sign changes. So one term's positive, one's negative, one's positive, one's negative. So you see that alternating of the sign. To create that, you have to take a negative number and raise it to a power. Because think about how even versus odd is going to make a difference in the sign of that overall term. And then for the 4th question on here, you had to find the 4th term. Again, it's recursive. So what you needed to do was you needed to find that first term, or the first term was given to you, but you needed to find the second term by taking 2 times the previous term and then subtracting 5 to get that -11, and then so on and so forth. You have to keep taking the term that you got from the step before and use that to find your next answer. So that is this idea of explicit versus recursive. On the next page, we're going to get into this idea of convergent versus divergent. We say that a sequence converges if when you look at the pattern and you see what's happening with the numbers, they approach a specific value. So what you're going to see is that the numbers keep getting closer and closer and closer to a specific value. It's like this idea of a horizontal asymptote when you look at a graph. And you see that the values are getting closer and closer to that value. Now, if a sequence does not approach a specific value and the numbers keep getting larger, so for example, you keep multiplying by 2, you're going to see that that would be a divergent sequence. So there's different ways you can do this. I think the best way is to use your calculator, but also if you guys remember things from first semester, you can also think about not using the calculator and just think about what happens as you sub in n values that would get higher and higher and higher. For part A, this is a rational function. If you guys remember with rational functions, we have this idea of top heavy, even Stevens, or bottom heavy. Remember that if something is top heavy, we say that there is no horizontal asymptote. If something is even Stevens, we look at the coefficients. And if something is bottom heavy, we say that the horizontal asymptote is at 0, so y equal to 0. So if you look at this problem, even without a calculator, I know that this right here is bottom heavy. So because this is bottom heavy, this would have a horizontal asymptote at y equal to 0, which means that the larger the values of n that you sub in, this is going to converge to 0. If you graph this and you change your window to high values of, x, we can fill in an x for n, you're going to see that this has a horizontal asymptote at 0, which means it converges. Now, for the next example, notice that this one is top-heavy. And remember that if something is top-heavy, there is no horizontal asymptote, which means that if you keep subbing in larger and larger and larger values of n, this is going to get larger and larger and larger and larger. So we say that this is divergent. And then on part C, if you notice on this one, this is an Even-Stevens problem. So remember with Even-Stevens, we would look at the coefficients. So we would say that this converges, and it converges to that quotient, so 5/3. Now, again, you can type this into your calculator and you'll see that for very large values of n or x, whatever you decide to choose, obviously calculator, you'd have to choose x, you're going to see that it's going to get very close to 5/3. Or even just by hand, sub in 100 for n and check to see what you get, and you're going to see that ratio is very close to 5/3. Now, for part D, this one's a little different because it doesn't give us a formula, but think about it. If you see that we start with 1, and then we're at a half, we're at a third, a fourth, the next would be a fifth, a sixth, a seventh, an eighth. You're seeing that that denominator value is getting larger and larger and larger and larger. Technically, if you wanted to write a rule for this, note that if this is the first term, this is like n equal to 1. This is the second term. This is like n equal to 2. This is the third term. This is like n equal to 3. If I wanted to write a rule for this, this is really 1 over the n value, which technically is also bottom heavy. So as a result, you would see that this one also converges to 0. So there's different ways you can think about it. Even just filling in numbers and thinking about 1 over 100, 1 over 200, you're going to divide that out and see that that's going to get you very close to 0. So please pause the video at this time and do the next set of problems. And then when you're ready to check, please resume the video. Welcome back. So for this next part of the notes, you were asked to take this sequence and first of all, figure out the pattern, then find the 6th term of the sequence and discuss if it converges or diverges. These numbers keep getting larger and larger and larger, or smaller and smaller and smaller. If you think about negatives, like a very, very large negative number is actually an extremely small number, but they're not approaching a value. So as a result, we would say that that diverges. Now, to write a recursive rule for this, remember I said at the beginning of the notes, you need to tell me what the first term is equal to. Well, that first term is equal to 2. Then, to write a rule, you need to say a sub n equals, and somewhere you need to have this a sub n minus 1, because that means the previous term. Well, think about it. What did you do to 2 to get negative 6? You multiplied it by negative 3. What did you do to negative 6 to get to 18? You multiplied it by negative 3. So you keep taking that previous term and multiplying it by negative 3. So that's how you'd write that recursive rule. And yes, both pieces need to be there. If you did not have a sub 1 equals, imagine someone trying to use your rule if that wasn't there, and I just had this. There's nothing I can do, because if I wanted to find the second term, I would need to know the first term, and there's nothing given to me. So you have to give that first term for this. Okay? Moving on, the next part of the notes is having you write explicit and recursive rules. So if you are given something that looks like number 7, and I say write an explicit rule, you really don't want to think about what are we doing to the first term to get to the second? What are we doing to the second to get to the third? That's recursive. You need to think about, my screen freezing, and let's open this back up. Crack my knuckles because I'm getting mad at my iPad. Dim fighting words. So we are going to, gosh, this is a never ending note sheet. Okay, no, we're almost done. Not really, but okay. So if you are going to write an explicit rule, the best thing to do is write under each term, this is n equal to 1. This is n equal to 2. This is n equal to 3. This is n equal to 4. So when you think about it, my first term, my second term, my third term, my fourth term, when you write explicit rules, think about what do you do to n to get to that answer. So if I'm going to write a formula for explicit, the numerator is always 2, but I need to connect the n value with the value in the denominator. So what am I noticing here? Well, I know that 5 is 5 to the first power, and 25 is 5 to the second power. So really, whatever the n value is, that is the power on 5. And then notice that is your explicit rule. I should be able to zoom in to only this last term. And if I sub in a 4 to my formula, I get that without knowing any of the previous terms. That is what explicit means. So that would be your explicit rule. Now, to find your recursive rule, it's a little bit different, because with recursive, you do want to think about, what did I do to the first term to get to the second? What did I do to the second term to get to the third? First thing you need to say is, what is the first term? So our first term here is 2/5. And then to find any term that comes after, don't forget to have this a sub n minus 1. I always put that there. And I want to think, what am I doing to the first term to get to the second? Well, I'm multiplying it by 1/5, right? Because the denominator gets multiplied by 5, but then I'd have to write that as 1/5. So I'm really taking the previous term and multiplying it by a fifth. And then that would be your recursive formula for that. You get better with practice. It's weird. The notation is weird, but when you do it enough, you practice it enough, you'll feel really good with it. Question 8, you are asked to find the fourth term, and phew, it's explicit. So that means all I have to do is sub in a 4 for all of my n's, and I can get that answer directly. Now, in my calculator, I can type this in, and I can do the 48 parentheses 3 divided by 2, and I'm going to raise that to 4 minus 1 is 3. So I'm going to get 162 as that fourth term. Now, will this converge or diverge? Even without finding any other terms of the sequence, I know the answer to this because I understand exponential functions. Guys, look at this ratio. Look at this value right here. We keep multiplying by 3/2, right? So we're going to take 41. That's going to be our first term. And then we're going to get our next term by multiplying it by 3/2. And our next term by multiplying by 3/2. Guys, 3/2 is really 1.5. Because that's greater than 1, these numbers are going to keep getting larger and larger and larger and larger. This is going to diverge. Now, if you're not sure with that, start typing in different numbers for n. You can graph this and look at different n values and see what's happening with the numbers. But you're going to see this is an exponential growth function, so it will diverge. Question 9, never-ending note sheet. Hopefully we're almost there. The end is in sight. Writing a recursive formula for the sequence. Always check when you're writing rules. Can you add a number? Can you subtract a number each time? I notice that here I'm adding 4. Does that pattern continue for each term? If that pattern continues for each term, then we can think about how we're adding 4 each time. So to write with that recursive rule, we would have to state what the first term is. And then remember, to write that recursive rule, we need to have a sub n minus 1. What am I doing to the third term to get to the fourth term? Oh, every single time I'm just adding 4 to the previous term. So use that expression. Like when you're writing recursive rules, think to yourself, here's you. You're looking real good. Haven't seen you guys in a while. Think to yourself, self, and spell it right too when you're thinking. What do I do to the previous term? Let's make that bubble a little bit bigger. Oh, previous term to get to the next term. And whatever you do to the previous term to get to the next term is that operation you want to include with the a sub n minus 1. All right, finally, the last one. Please be a good one. The last one is also about finding that fourth term of a recursive sequence, but you'll notice for this one, it's a little bit more involved. The first term is 3. If I want to find the second term, so a sub 2, I'm going to sub in a 2 for all the n's. Notice then that would give me a sub 1 minus, don't forget to sub in a 2 for that n. This will change for every n value, so be careful that you don't keep putting subtract 2 plus 2. That's only for that second term. So that means that I'm going to take that value of 3 that I got for that first term and do 3 times 3, 9, minus 2 plus 2. I'm going to get an answer of 9 as my second term of that sequence. Now to find the third term, if you see the pattern, you're basically taking 3 and multiplying it by the second term, but be careful that you subtract 3 and add 2. You need to make sure you're changing that middle term every time. So with that being said, I'm going to take that answer of 9. I'm going to get 3 times 9, 27, my age, no it's not, minus 3, 24, also my age, and then add 2, 26, I would take that as well, any of the above. And then finally, to actually answer the question, we get to that fourth term by taking 3, and we're going to multiply that by the third term. We're going to subtract 4 this time and then add 2 at the end. So we have that value of 26. I'm too lazy to get out the calculator, so let's 18 carry the 1. That's what, 678. I hope my math is right. Minus 4. So we get 74, and then plus the 2, 76. So I know that that was a lot, but hopefully it wasn't overly challenging for you. I feel like it's pretty straightforward. It's just a lot about finding patterns and understanding this new notation.